Okay, this is the review for Chapter 8. Okay, in problem 1, they give you the information for a triangle. So first, draw your triangle. Put A, B, and C wherever you want. And then put the information in that they've given you. They gave you 103.7 for this angle. And then they've given you two sides. Side A. The drawing is going to help you determine whether it's law of sines or law of cosines. Okay, and the units on these numbers were centimeters. You can put that on your final answer. Okay, it's law of sines because of that pair right there. And I want you to notice one thing, that in this problem, all you've been given as far as angles is this one angle. And anytime you only have one angle, you are in the ambiguous case. And what that means is that ambiguous means that this triangle can possibly be drawn one of three ways. Perhaps this is the only way it can be drawn. Perhaps it's the case where there's no solution, so that you find out quickly into the calculations that the triangle really doesn't exist. And perhaps it can split into two different triangles. So we have to test that whenever we only have one angle to start with. And where we're going to test it is right upon calculating our first answer, which is going to be angle A. So let's go into finding angle A. So it's side of angle A across from side A. And then for the other fraction, it's sine of angle B divided by side B. Cross multiply this 298 up into the numerator. So it's not there. Cross it out so you don't use it again. Okay, put all of this into the calculator. You now have sine of angle A on the left side. And for this side, it is sine of 103.7 times 298. Divided by 1635. I got 0.1771. Turn this around into an inverse statement whenever you're looking for an angle by just switching the angle and the decimal. Switch the sides they're on. Okay, so now we're going to do inverse sine in our calculator of 0.1771. And I get 10.2. Okay, so this is the very first answer that we have found for ourselves. So put that 10.2 in there, but consider whether there is an alternative angle at this location. Okay, and the way you make that consideration is by going 180 minus what you've just found at that location, 10.2 degrees. Put that in your calculator if you need to. It's 180 minus 10.2 is 169.8. So let's imagine whether this is even a valid consideration. If this angle, rather than 10.2, was this, imagine having that angle right there. You would have 169.8 plus 103. You're well over the 180 degree limit just using these two angles, so you have no room to give angle C any number of degrees. So this means that this triangle can only be drawn this one way with the 10.2 and the 103.7 because 169.8 does not work there. It makes you go over the 180 degree limit. So let's just stick with this. We're not going to use that. And let's complete this triangle. Next easiest thing to find would be angle C. Just be 180 minus the other two angles that we have in the triangle, which the sum of those, I can just subtract both of those at one time by adding them together. That would be 113.9. And that tells you what's left for angle C. Okay, so 180 minus 113.9 gives you 66.1. Okay, so we have all three angles. All that's left is finding side C right here. Okay, so side C, let's set up two fractions going back to lost signs. So it's side C across from angle C, which is the 66.1 that we just found. Set up another fraction on the right-hand side, sides on the top, the side on the top. So I'm going to use the A pair, which has side A 298 and across from it an angle of 10.2 degrees. Okay, isolate the unknown, which means you're going to have to swing the sine of 66.1 right up into the numerator. So it's not there anymore. So it's side C, 298 times sine of 66.1 divided by sine of 10.2 degrees. So I get side C is 1538.51. Okay, and I think I'm just going to round that to the nearest whole number since the other sides are to the nearest whole number. Okay, when you list your answers on the test, you're going to take all the answers you've gotten out of your scrap work. Like the very first thing that we found was angle A, and you're going to move them over into the answer column. So that was one of the answers we found. When we decided that this is the only thing that angle A could be, we then found angle C, which came in at 66.1 degrees. And then finally, based on angle C, we found little side C, which turned out to be 1539. So this would be what you're going to put in the answer column for number 1. Okay, number 2 is the same sort of problem. It was also, the numbers were given in the same location. I was just giving you a couple to practice on that actually turned out the same way. So in this problem, you were given side A, you were given side B, and I believe you were given angle B. Okay, this time they gave you 34.8 to practice this one more time. Side A came in at 24.5, and side B was given as 10.92. Okay, this pair, just like in number 1, tells you that you can use lost signs. Okay, so we're going to do, and then we're going to be going after angle A. So I'm going to put angles on top. So I'm going to go sine of this angle that I'm looking for divided by side A is equal to sine of angle B, 34.8 over side B, which is 10.92. Isolate the unknown, which is the sine of angle A, by swinging this denominator up to the top. Cross it out and put all of this as a calculation in your calculator. So it's sine of 34.8, close up the parenthesis, times 24.5 divided by 10.92. Be careful when you're putting this in the calculator that you close the parenthesis before typing that in, or it'll come out wrong. Okay, so now what I got here is 1.28. And even though the information was in the same location as problem number 1, this actually comes out with a different answer. This is actually a very short problem because right when you go to do inverse of the decimal, this 1.28 is too big for the restricted domain belonging to inverse sine, which if you don't remember what the restrictions were from the inverse sections, then just try pressing it in your calculator. And you'll discover pretty soon that you can't go any further with this problem, because you'll get this message, quit, error, which means that this triangle does not exist. And in terms of solving the triangle, what that means is that there is no solution. Okay, so for number 2, you would come into the answer column and only give this as your answer. Okay, number 3. Okay, for number 3, we have sides A, B, and they gave us an angle called beta. I'm just going to let the beta be angle B. I think it'll be easier for you to follow. I think in the next problem we're going to be forced to use the alpha, beta, and gamma. Okay, so draw your triangle. You can actually put the A wherever you want, the B wherever you want, and the C wherever you want, but then you have to put these numbers where they belong. So B is 10 degrees. That makes side B over here, and side A would be across from angle A. Okay, so in all 3 of these problems, 1, 2, and 3, are given 2 sides and a non-included angle. Okay, so now let's begin deciding what you're allowed to use. And again, because of this pair right here, an angle and a side across from the angle, that makes it law of sines. I am going to be finding this pair just as I did in numbers 1 and 2. So I'm looking for an angle. So I'm going to put angles on top, divided by side A, and then over here I'm going to put sine of angle B divided by side B. Cross multiply that 6 right across the equal sign and cross it out so you don't use it again. Put all of this in the calculator. That'll be equal to sine of angle A. So it's sine of 10 times 6. That's my numerator, divided by 3. And I get 0.3473. Turn it into an inverse whenever you're looking for an angle. Okay, so inverse of the decimal 0.3473, and I get 20.3 degrees. So you can go ahead and put that right here. But again, because you were only given this one angle right here, you are in, again, the ambiguous case, where you have to decide whether this is no solution, and if it was no solution, it would have happened right there. You would have went to go find the inverse, and this number would have been too big, and you would have gotten an error. So it's not the no solution case like number 2. Is it just one solution, or is it 2 solutions? So right when you find this second angle, you're going to consider, is there an alternative angle that can be used at this location, angle A? You start that consideration by going 180 minus the angle that you've just found. And I get 159.7. Will this work in place of the 20.3? So imagine the 20.3 wasn't there, but the 159.7 was. You'd have 159.7 plus 10. That's 169.7. So you haven't gone over the 180 limit. So there is room for this angle. So not only can the triangle exist like this, but it can also be drawn a second way. So this is the two triangle solution case. So instead of the 20.3, you could have 159.7 degrees, the alternative angle. Everything else besides where I just put the 159.7 was given. All the givens go right back where they were. And you are going to complete both of these triangles. Both of them at this point now require the third angle, angle C, and you have to find side C for both of them. So two more things for each side. The easiest thing would be to go after angle C first, because all you have to do is subtract. Let's see, I'd be taking 30.3 away from that for angle C. So this would be 180 minus 30.3, 149.7. Okay, and then side C, now that I have angle C, I could find side C. So finishing this off, I'm going to find side C right up here. Side C divided by sine of angle C. And then in my other fraction, I'm going to use the 20.3 and the 6. Side on top, sine of the angle on the bottom. Okay, then I'm going to swing sine of 149.7 across to the other side, right up there. I can't fit it there. I'll just write it here. It's 6 times sine of 149.7 divided by sine of 20.3. Okay, you're doing side C. Put all of that in your calculator. So 6 times sine of 149.7 divided by sine of 20.3. Press that in again. 6 times sine of 149.7. That answer divided by sine of 20.3. So for this, I got 8.7. Okay, now complete this triangle, going again after angle C first. So that would be 180 minus the sum of these two, which is 169.7. So 180 minus 169.7 gives you 10.3 degrees right here. And then finally go after little side C. So I'll do it over here, just like I did it for this problem. Little side C over angle C, which is the 10.3 degrees that we just found. One more fraction. I'm going to use the B pair. I'm going to use side B over sine of angle B. Swing this to the other side so that the unknown is isolated. So this is not here anymore. And we're going to put all of this in the calculator. 3 times sine of 10.3, close it, divided by sine of 10 degrees. And I got for that approximately 3.1. Okay, again with your answers, you're going to take them out of all your scrap work and remove them to the side. So especially important for this one because I'd have to search all over to see what's your answer. So you're going to go like this. You're going to go triangle 1 and list everything that you found in the problem. We found angle A first, so call it A1, meaning it comes from triangle 1. We found it to be 20.3 degrees. Next thing we did is subtract to get angle C. That turned out to be 149.7. And then last thing we found was side C. And side C turned out to be 8.7. You can hang little ones off of each of these answers. Then we're going to talk about triangle 2, the second triangle that it's split into. We found the same three things. Angle A, but we'll call it subscript 2 because it's from triangle 2. And it turned out to be, in this case, 159.7, the alternative angle. Then we found angle C in the second triangle, which was 10.3. And then we found side C, which was 3.1. Okay, that's number 3.